Okay, I just want to run through these optimization problems. I think some of these I've done in class, some of them I haven't, so there may be some repeats, but here we go. Find the point x, y on the graph of y equals square root of x and nearest the point of 4, 0. So nearest is the key point there, or the key word there, I mean, that tells us that this is an optimization problem. So then we have to ask ourselves, what are we trying to optimize? So the fact that it's nearest, that means we're trying to make a distance as short as possible. So we're trying to minimize the distance from a point x, y, x, y to the point, to 4, 0. And so we need to come up with an equation that represents that distance. Now before we write that equation, I think I did this after I wrote the equation in class, but before we write the equation, we can think about x, y. We're actually looking for the point x, square root of x, aren't we? Because y is described as square root of x. Okay, so now I'm ready to write the equation. So the equation would be d distance equals, so to find the distance from 4, 0, 0 to x, square root of x, we just use the distance formula, which is the square root of x minus x, which would be 4 minus x squared, plus y minus y, which would be 0 minus the square root of x squared. So there's the equation of the thing I'm trying to optimize. So then now I just optimize it. So I take the derivative. So d prime is equal to, and this whole thing, actually I guess I should simplify this a little bit. This would be 16 minus 8x plus x squared. And that square root of x squared would be just x plus x. Whole thing squared, or I'm sorry, the whole thing to the 1/2 power. And then if we simplify that a little bit further, we would get 16 minus 7x plus x squared to the 1/2 power. Okay, now we're ready to take the derivative, so that would be 1/2 times 16 minus 7x plus x squared to the negative 1/2 times the derivative of the inside, which would be negative 7 plus 2x. And that would be equal to negative 7 plus 2x over 2 times the square root of minus 7x plus x squared. We set that equal to 0. So we have to ask ourselves what will make the top 0. And that would be 7 over 2. So x equals 7 over 2. And which of course is 3.5. And you could also ask what makes the bottom 0, because that would make it undefined. So we want to know what makes the inside the square root 0, so you can use the quadratic formula. So that would be x equals negative b, which would be 7 plus or minus the square root of 49 minus 2 AC, so that'd be 2 times 32 is 64. And oh, we get a negative in the square root, so that's not going to produce any answers. So 3.5 is our only critical point. Which we assume it probably means that it's a maximum, a minimum. We could check though. 3.5. If I plug in 0 in there, I get negative. And if I plug in, say, 10 in there, I get positive. So sure enough, it's a minimum. So then we go back and read the question. The question was, find the point on the graph y equals square root of x nearest the point 4, 0. So this is an x value, so this must be 3.5 comma square root of 3.5 would be the point that I'm looking for. That would be my answer.